Hello everyone and welcome to the part 3 of Introduction of Statistics. From the previous videos, you will now be able to do data collections and presentation processes, such as frequency distribution tables for qualitative data, such as bar and pie charts, frequency distribution table for quantitative data, single class width for group data, relative percentage and cumulative frequencies, such as histograms, polygon, ogive, and their shapes. But what I haven't gone through is stem and leaf display and dot plots. They are super necessary, but I won't do them now, and if you wonder what they are, please Google them. In today's video, we are going to look at central tendency, and the measure of it. So what is central tendency? So in statistics, knowing the value of each element in a dataset in relation to the average value is crucial. The average of all values in a dataset is indicated by the central tendency. Considering a 88,000 annual compensation for a position in the media industry, what exactly is the core tendency, may you ask? We can determine whether 88,000 is a good compensation by looking at the average income of all similar positions. And that's the reason why you can determine if 88,000 is good or not. However, ungrouped data is a collection of data that has not been divided into separate categories. For ungrouped data sets, there are three ways to assess the center, which is mean, and you all know this from your previous math courses and whatever, but in statistics, means are essential. So the mean for ungrouped data is obtained by dividing the sum of all values by the numbers of the values in the dataset. Right? And this is the equation or formula for population mean. If you want to do this equation, you need to make sure that you have all possible outcomes and etc. And this one is sample mean. So this is mu and this is x bar, right? It's almost identical, but this one is used for sample and this one is used for population mean. And also remember to, if you're going to do calculate the mean for population mean, make use of the capital like the big letter N, and for sample mean small n, I mean the difference is only the symbols to distinguish the difference between the sample and population mean for future calculations. But we can look at this question: the largest companies in England 2020. So we're going to look at the largest companies in England 2020. We're going to find the mean sales for these companies. So let's look at it. So we're going to use, it's a sample, right? The largest companies. So it's a couple of companies that is in England and are considered to be the biggest or largest. So our sample would be these hand-picked big companies. And as you can see here, we have companies, sales of each company, and the number of samples. This company A, B, and C, and D, I just put it out. It could be Apple, Facebook, Google, Tesla, or whatever. And it's measured in billions, let's say. So what we need to do is that we take this 766, which is the sum of the company, of the sales, sum of the sales. It should be an X here. Let me write an X for sum of, that's an X. Sales of company X, So the sum of X is 766. And we have 4 different samples, And this one appeared for some reason, I didn't even notice it. So this is how you calculate it, basically. So you take EX, which is this part, divided by that one. So that will give us that the mean sales for these 4 companies are 191.5 billions. So if you are going to construct a study or a research investigation, whatever you like, and you will look at the largest company in the whole world, and you will take, like, say 10 of them, yeah? So you have 1, 2, 3, 4, etc. And then you just list what their sales are in that specific year. This is 2020, so let's take 2019. Yeah, and let's say this one had 4 billion, 6 billion, blah, 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 blah. All you gotta do is just sum these up to get your EX or sigma of X. Yeah, and you divide that by N, small n. Yeah, pretty simple. Next one. All ages of employees in a company. So the reason why I highlighted all is to make sure that you understand the difference between when you use a sample, like the largest companies, which means that there are more companies in England, right? There are more than 4 companies, right? But here we said all ages of employees in a company. So all means population mean. So we're going to take that formula right here. So population, because we are measuring all of the employees, yeah? And we have the employee A, B, C, and D, yeah? And employee A has the age of 20, 25, 30, 16. So what we need to do is that we need to take the sum of X, the sigma of X, which is 91, yeah? So 91 divided by 4, because it's 4 samples. The population is 4, right? So if you would take, for example, a company of 50, let's say this was 57 employees, yeah? Then you needed to construct a table with 57 different people with 57 different ages, yeah? And that gives us that the mean of all the 4 employees is 22.75 years old. Yeah, simple and straightforward. So now we're going to talk about outliers and how it affects the mean. So as you can see here, we have the 2 tables. This one is from the previous one, and this one is exactly the same. So you see employee A, employee 20, you see they're equivalent, except for this one. I changed 16 to 81 to show you that outliers matter when it comes to the mean. And why does it matter? I'll show you. So as you can see here, that if someone were to ask you to calculate the mean for a specific company, the population mean for a specific country company, it should look like something like this, you know? And then you get a basic understanding that, oh, okay, on the company ABC, right? Company ABC. Company ABC, the average age is 22. So the people are pretty young there, you know? And you can do the estimation by just calculating the mean. But now when we have an outlier, he's 81. Right? I don't know if he's a bit too old to work, but for demonstrating purposes, he's 81, yeah? And as you can see, the mean value changed from 22.75 to 39. So if you would construct a population mean for the same company, but this 16-year-old left the company and they replaced the 16-year-old with an 81-year-old, the average would be 39. And your view on the company would change. Instead of you going, oh, 22 years old, there are a couple of kids, you know, I don't want to work there, to 39. Yeah, that sounds pretty reasonable age to work. Yeah, I can go along with people who's 39. So you can see the difference with one outlier, right? And this happens with all kinds of statistics. That's why there's a lot of programs and techniques you can do to to minimize the outliers and that kind of stuff. Yeah, but just be aware that whenever you do mean, outliers matters, right? So if you would choose between going to a company that has the mean value of HS of 22.75 or 39, it might impact your decision making by the mean value, if you understand what I mean. Yeah. Next one. So median, it's written twice. Very nice. Is the value of the middle term in a ranked dataset, normally in ascending order. Find the median value below. Okay. So when it comes to the median, it's essential to look at the middle value, right? But if I just did that now, it wouldn't be correct. Excuse me. Why? Because you need to list them in increasing order. So you need to either start by the lowest and finish at the highest, or start by the highest and finish by the lowest, and then you pick a middle. That's how it's done. So as you can see here, I rated it from the lowest here to the highest. So the median would be 445. That is how easy it is to calculate the median. But we're lucky now because we have a value that is in the middle. As you can see, we have 1, 2, and 1, 2. And this one is in the middle. What happens if there are 6? When you have 3 on this side and 2 on that side, and 3 on this side and 2 on that side. Let's see how we're gonna do that. As you can see here, we have a plenty amount of numbers, and the calculation is already showing, so I'm guessing that you already figured out. But if you have a number where you can't pick a middle, you have to take a middle right here. And what you're gonna do later is that you take the plus 12 plus 13 divided by 2, right? 12 plus 13 is 25, and 25 divided by 2 is 12.5. Simple. Yeah, and that's how you calculate the median in simple ways. Yeah. And the mode, how do you calculate the mode? You all should know this from math courses in your previous studies, but I mean the mode is the value that occurs with the highest frequently in a data set. So the one who shows the most, so 80, 80, it's 3 80s, yeah. 80, let me see, 77 is 1, 70, yeah, okay, I guess it's 80, as you can see. I mean, it's 3 times 80. It's pretty simple, it's straightforward. So now you know mean, median, and mode. It's not that hard, yeah? Pretty simple. Next one. Positions of mean and mode for a symmetrical histogram. And as the previous video, you know what the bar chart is. A histogram is just a joint one, you know, as you can see. And the median is in the middle, right? The mean value is right here. And the mode is on the right side. Yeah? And this is normally distributed. Next one. Positions of mean, median, and mode for a histogram skewed to the right. Median in the middle. And you can see the difference in the mode. So this is from a symmetrical histogram. Mode right here, mean right here, and median in the middle. Pretty simple and self-explanatory. When it skews to the left, mode, median, mean. Simple. And that was that for part 3 of statistics. In the next couple of videos, it's going to be more detail, more mathematics, and hopefully you understand how to work out all of these measurements. I'll see you in the next video.